Let us calculate the integral of secant squared of 3 theta d theta. So independent variable is theta, and we're going to calculate this integral. How do we calculate this integral? Let us use u-sub. Let us take 3 theta to be our u. So u is 3 theta, and du is 3 d theta. So d theta can be written as du divided by 3. This integral becomes the integral of secant squared of u, and wherever you see d theta, just write down du divided by 3. In turns, this integral can be written as a third integral of secant squared of u du. The integral of secant squared is tangent. Remember that. The integral of secant squared of u du is tangent u plus constant of integration. This is the formula that we learned before. Remember that. The goal of using u-sub is to simplify the complicated integral into something familiar, something that we saw before. This integral in turns can be written as a third tangent of u plus constant of integration. What was u? U is 3 theta. Just substitute it back here. Your integral is a third tangent of 3 theta plus constant of integration. This is your integral, the integral of secant squared of 3 theta. What if you're interested in calculating the integral of tangent squared of theta times secant squared of theta d theta? What is this integral? To calculate this integral, we can use the u-sub and take tangent to be our u. Let u be the tangent of theta. Remember that from calculus, the tangent is sine divided by cosine. In order to calculate du, we have to apply the quotient rule. This is the derivative of sine times cosine minus sine times the derivative of cosine divided by the denominator to the second power. And since you are taking the derivative with respect to theta, this is going to have d theta next to it as well. So again, remember that if you have f divided by g and you want to take the derivative, quotient rule says it is f prime g minus f g prime divided by g squared. So your du is equal to the derivative of sine is cosine. You have cosine theta times cosine theta minus sine theta, and the derivative of cosine is negative sine. So you get a plus sine theta divided by cosine theta to the second power d theta. So du is equal to cosine squared of theta plus sine squared of theta divided by cosine theta to the second power d theta. Or du is equal to 1 divided by cosine theta to the second power d theta. This fraction in terms can be written as 1 over cosine theta to the second power d theta, and by the definition, 1 over cosine is secant. So du is secant theta to the second power d theta, or du can be written as secant squared theta d theta. So if you ever forget about the derivative of tangent, you can apply the quotient rule, and as you can see, if u is tangent, du is secant squared. Well, why it is helpful for us? Because if I take u to be tangent, I already have du, which is secant squared d theta. This is my du. Well, it makes life much more easier. You have the integral of u to the second power du, and we already know how to deal with this integral. This is 1 divided by 2 plus 1, u to power 2 plus 1 plus c, or u third divided by 3 plus c, but our u is tangent, so substitute this guy back here. This becomes tangent theta to the third divided by 3 plus constant of integration.